Okay, everyone, welcome to lecture 3. This is going to be relational databases. So building on the databases lecture from last week. So just a few announcements real quick. PA3 is due next Monday. PA2 should be submitted by tonight. You can use your slip days if you need. Some students were saying that it wasn't open, so I closed it and reopened it. And hopefully that should fix it. But if for some reason you can't see it on your CMS, just come up after class and we'll try to fix that. Another just last announcement, make sure you are in the CMS and Ed. Today or tomorrow is going to be like the last day to finalize it. So make sure you're on it or else after like the next 2 days by demo, you won't be able to be added. And then also PA1 grades are coming soon in this following week. And if you have any concerns or issues, you can reach out to the person who graded you. You'll be able to see like their name and net ID at the top of the feedback file that you'll see on CMS. So if you ran the test file, everything passed for you, but then they didn't grade you correctly, reach out to them and hopefully you can fix it with them. Yeah.
Where can I find the weekly feedback?
The weekly feedback form?
Yeah.
Yeah, that should be in the textbook at the bottom when you scroll to the assignment handout. And yeah, make sure you guys do the weekly feedback form. I'll be going through at the end of every assignment to make sure you did it. And if you didn't, then you will lose points. So make sure you submit that after every assignment. And yeah, it's found in the textbook at the bottom of the assignment handout where it tells you how to submit the assignment as well. So yeah, jumping into a little bit of review real quick. I know we've gone over this a lot, but we want to emphasize it. The client server model, the client, which is you guys, the phone, laptop, or computer, and the server is the large computer that runs the backend code and handles the data, and it takes in requests from the clients. So then the route is triggered, some CRUD operation is performed, the server sends an SQL command to the database returns some of the data to the server, like that, and then the server returns the data retrieved from the database as a response to the client. So that's the broad overview right there. You send the request, then you get the SQL command, then the database sends the data back to the server, with the server then gives the response to the client. So now we're going to jump into the different types of databases. So first, the single table database. And so here, the table structure information into rows and columns, like I previously mentioned last week. And the columns represent a field with a defined type. So an ID would be like, or an example would be like ID, color, or shape. And the rows represent a collection of column values. So if you had ID, color, and shape, the rows would be 1, red, and square. Query and manipulate the data with SQL. So that's, like I said, query is kind of search, and you can manipulate the data as well with insert and delete and edit. And you use the different SQL statements to do this. So remember those from last week are select, create, update, and delete. So yeah, just going over the course overview, this week is relational databases. And you can also see all the following weeks right there. Abstractions will be next week. And then containerization and DevOps will be week 5, following with some deployment. And you'll soon have the hack challenge. So any questions so far about just the review or the course? No. Okay, perfect. Then moving on, we're going to now jump into the main point of this lecture, relational databases. So a quick overview. They basically allow relationships between data, as you can kind of assume from the name. And so in PA1, we had several comments for one post, but how do we know which comments belong to which posts? How do we know which users are friends, which transactions relate to senders and receivers? So we did this earlier in PA1. A lot of students did this by putting the comments in the actual posts dictionary, but there's another way to do this, and that's through relational databases. So one example is as follows. We have a users table and a post table. We can see Tony right there has ID 1 and Ayush has ID 2. In our post table, we can see that we have the following fields, ID, text, and user ID. And we see that the user ID field refers to the ID of the user that created the post. So deleted eatery codebase, which is actually just an example, relates to user ID 2, which would relate to Ayush, meaning Ayush did that action. Versus I ran 10 miles relates to user ID 1, so that would relate to Tony. And so you see that column basically shows which ID of the other table you want to relate to. So you can see here, the ID relates to Ayush. And so yeah, so now jumping into foreign keys. which is part of the relational databases. The user ID in the previous example is called a foreign key, and the foreign key is a column in one table that specifies or identifies a specific row. It's also called a secondary key, but we'll usually use the term foreign keys. So like I mentioned, the user ID refers to the ID belonging in a user row, so that is a foreign key. And the foreign key column signifies the relationship between two databases. So to summarize, we use a foreign key to represent a relationship between two separate tables. So that's the key with relational databases, and it's how you're gonna reference the two. So jumping into relationship types, we have three types: one-to-one, one-to-many, and many-to-many. So in a one-to-one relationship, row X in table A refers to one row Y in table B, and row Y in table B refers to one row X in table A. Basically, each row refers to each other, so they have a one-to-one relationship. That's where the name comes from. So the entry with ID 10 belongs to the user Tony, right here. And the entry with ID 20 belongs to Ayush. And next we have a net ID with the two entries. We have the user ID field, which that would be the foreign key that specifies which user ID this net ID corresponds to. So we see that specific net ID of AA2328 corresponds to Ayush, and AKM99 corresponds to Tony in the users table. So right there, it's highlighted. You can see that's how they relate, and it's being used by the foreign keys, which is the user ID column. So here is the actual syntax for SQL. So we see in this example, we have create table user, ID, and again, we use the integer primary key auto increment. Then we have name, text not null, basically meaning that you have to input something and it's of type text. So as you can see, we have it right there, ID and name. And then we also create table net ID, and that has ID, net ID, and user ID. And we can see here that the main point is with the user ID field in which we put integer unique. So the unique keyword signifies that this is a one-to-one relationship, meaning no two net IDs can have the same user ID, which makes sense. No two students have the same net ID. We want a specific net ID to correspond to a specific student. Also, no two users, no net ID can belong to multiple users, and no users can have multiple net IDs. The relationship works both ways. And to represent this, we then write foreign key user ID. So the user ID, like I mentioned, is the foreign key column. And then we write the keyword references, and then we put the user and in the parentheses ID. So we know specifically what the foreign key is referencing. So we know how to relate the two. So to sum up, the user ID is a foreign key that is unique, and it references the ID column in the user table. So let's say we want to insert in a one-to-one table. We assume empty tables initially, and then we insert into user. So we insert into the user table, and we put into the name column with a value of Tony. And then we insert into the net ID table in the columns of net ID and user ID, the values of his net ID, AKM99, and the user ID, which would be 1 for Tony, respectively. And notice how now with this, the user ID of 1 will reference the entry in the user Tony. Because Tony, like we previously mentioned in the tables, has an ID of 1. So that's how when you insert it, that key part of the values is that 1 is necessary to make sure that you keep the relationship between the two tables. So now jumping into a different type, one-to-many. This is when a row X, so one random row in table A, refers to many rows, like as Y2, Y1, Y2 in table B. But row Y in table B refers to only one row in table A. So you can see the little green diagram. We could have multiple rows in one table referencing only one single one in another table. So an example of this would be like baseball teams and players. So each team can have many players, right? But each player can only belong to one team. So in this case, the team would be like the singular green box on the left, and the players would be the 3 on the right. They all belong to a team, but each player only belongs to one specific team. So here's an example. We'll use songs for this one. So here we have, ID of 10 for Igor, and ID of 20 for 444 for the albums. And then we have the song table. And that each has another unique ID, 30, 40, 50, and we have Earthquake, I think, 444, and Moonlight. And you can see the team ID is basically like the album name, and that references respectively Earthquake and I think to the correct album of Igor, and 444 Moonlight to the other album, 444. And so we can see here that we can have multiple songs or multiple fields in the song table referencing that one specific field in the album, but we don't have the album referencing multiple in the song table. So right here, just highlighting what I just went over. And again, so now this is how you would use table syntax with SQL for one-to-many insertions. We have, again, our album with the ID and the name, and our tables with ID, name, album. And then we have integer, and we keep not null here is key, because you cannot reference something with a null value. So you have to specify that's not null. And then once again, it's pretty similar. You put the foreign key, whichever album you're using as the foreign key right after, references, and then you put the specific field or row that you're going to reference. So in this case, it would be album and then ID because we're referencing the album ID. And then for our insertion, we insert the song table with the name Earthquake and album ID 10. So again, specifying exactly which ID the song relates to in the album table. And if we wanted to get all the songs, remember the keyword select with the asterisk, and we say select asterisk from song where album ID equals 10. So basically that takes the album ID, which has ID 10, so in this case it would be Igor, and it gets all the songs which belong to that album. And the last relationship is many to many. And so here you can see basically row X refers to many rows in table B, and row Y in table B refers to many rows in table A. So the easiest example that we can think of here is students and courses. So let's say courses is on the left, students is on the right. Each student can be in many courses. So a student can point to multiple different rows at the courses table, but a course can also have many students. So each course is going to also point to different student fields in the table. And we'll have a more concrete example in a second. But the implementation, you have three potential choices and two are not ideal. So you can have multiple columns to store more foreign keys. So you can have like the foreign key in the students and the foreign key in the courses. You could have a single column to store a list of IDs, or you can have a join/association table. And the association table is going to be the most ideal. We're going to see why in a second. So here, for example, we have a student table. So we have a couple net IDs and some courses that they're enrolled in, and each one has their specific ID. This is an okay implementation if every student is taking 3 classes, but what if a student wants to take more than 3 classes and overload a particular semester? In that case, we need to make more foreign keys and more entries, which is not ideal. So in that case, it would look like this. Let's say they also want to take 2000 and 3110. We're now overloading the table. And we could make entries for these other students, but it's not a great use of space, and it's not good for space efficiency. As you can see there, we'd have to put null for every other students, which is just basically taking up space for no reason, since the null field still takes up space, but we're not actually storing any data in it. It'd be the same thing if you added more students, you would have even more null depending on the courses. So the best way to do this is to actually have a single column to list of the IDs of students. So here you can see we have like a student table and a course table. And we see the students have their courses and it lists which ones. So 1110, 1998, and student 2 has course 1110. And you can see in the course table, we have students 1 and 2, which means both students are enrolled in 1110, which makes sense as we look at the table. And only one student, student 1, is enrolled in 1998. So right there, you can see they correspond to each other. And as we add more, we then see that if we add something to the students table, it will correlate to the course table. But then we also need to add it to the students column in the course table. So we'd have to then fix it, change it, update it, and include that student. So the easiest way to do this is with a join or association table. And so here we can see we took away the courses and the students and we made it into a separate table right here. And here we have now just net ID and ID for students, ID and title for course. In our association table, we have a student ID and a course ID. And basically what this table highlights is that you have a student ID of 1, which would highlight to SN685, and then they take their respective course 1110. Then you have another student ID 1 who's enrolled in 1998, and you have another student ID 2 who's enrolled in 1110. So this table is basically doing the same thing that we did earlier, but in a way more organized and easy to access format. So you can see here, the ID1 will then correspond to those 2 entries and those 2 courses. And we can see for both those students, they are in 1110, so they're going to have the corresponding fields in the association table. And that way, if we wanted to add a new student, instead of adding one to each separate table, we just add a new entry into the association table with the respective ID and the course. So it's a lot easier to add and manipulate the data when you have the association table. So here are some join table syntax. So you have the ID, which is the primary key and the net ID, and you have your course, which is the ID and the title. And then here you can make your new table, create table join, and that's going to be the join/association table. And you can see here, we're going to have ID and then course ID and student ID, which we saw in the table previously. And then here is where you're going to write 2 foreign keys because each course ID is going to relate to the course table and student ID is going to relate to the student table. So like I mentioned, that means those are foreign keys if they relate to one another. So you add those 2 foreign keys when you create the table. So you do foreign key course ID references course ID, and foreign key student ID references the student ID. So that was it. It was a very brief lecture, but also it's very abstract. So if you have any questions, please raise them now before we head into a short demo so you can actually see how this works. Yeah.
I'm a bit confused for the 1 to N, for N to 1, how, like, what would you do for like your SQL?
For which one? The 1 to
For 1 to N, or like 1 to many or?
1 to many?
Yeah.
Yeah, so the 1 to many, we can go back. There we go. So this is the 1 to many. And so for the table, that's the table right there. You can see how it relates. And this would be the actual SQL syntax. So we create the table album, and then we create the other table song. And the one that's going to have multiple fields pointing to, that's one that we write the foreign key into.
Okay, so for album, you wouldn't have like a list of songs then, or?
No, you would not. So the album would then not need to reference or have the list of songs because the songs are going to reference the album.
Yeah.
And they do that with that foreign key right there, album ID. When you need to have it both ways, that's when it becomes a many to many. And that's where it becomes easier to create an association table. In other words, a third separate table that connects the 2. Any more questions? Yeah.
This one you do, says interview not known.
Mhm.
And the 1 to 1, it says integer unique. What was the reason for that?
Yeah, so the only difference is that unique kind of specifies that's not going to be null, but we use unique specifically for 1-to-1 relationships because unique is an SQL keyword that signifies that it's a 1-to-1. So in a 1-to-many, we need to specify that's not going to be null, but we can't also write unique because then it's not a 1-to-1 table, it's a 1-to-many. So the unique keyword is specifically for 1-to-1 relationships. So you would only use that with a 1-to-1, which in other words would be like the students and the net IDs. Any other questions? Okay.
Wait, have we learned a way to store multiple values into the same, kind of the same like element, in the table? Like to store like lists as like a single entry?
That was kind of part of like last week's with the databases. Do you mean like storing lists in like one field, like one entry? Yeah, I mean, it's basically each, if you go to like a table example,
Yeah, wait, if you go back to the original like students.
Yeah, like this one?
You know, the one where you had the courses listed as.
Yeah.
The list of every energy.
Oh, okay, so this one. Right,
Yeah.
wait, this one, yeah, so, what was your question? Sorry.
Like how to store multiple courses under the same within the
Oh,
same-
yeah, so that would basically be just like a list format or anything else. Yeah, that could be in a bunch of different formats. List would probably be the most ideal. But the whole point actually of like this one is that that's like not an ideal way to do it. Yeah. So like going back, there was like the three ways to do it. You can do it with multiple columns to store foreign keys or a single column to store a list of IDs. And those are the two that are not ideal. And then the association table is the most ideal. So that's actually part of why the association table is more ideal. So you don't have this confusing list of a bunch of courses corresponding to one student. Instead, you can make, as you see here, like a whole separate table. And that way, each column will still have the one value. Okay, any more questions? Since you'll be using this in your next assignment, and I think it's a concept that a lot of people find very difficult. So are there any more questions before we move on? No. Okay, perfect. So then that's gonna be the part for the lecture, and we're gonna jump into the demo, and hopefully that will make things a little bit more clear and less abstract.